Welcome everybody to another Kuta worksheet tutorial. We're doing solving systems of equations, this time by elimination. Now, what does it mean to solve a system? To solve a system means to find the place of intersection. That means we are looking for an x coordinate and a y coordinate. We're going to have two lines intersecting at some point, and we want to know exactly where it is they cross. Now, you can do this graphically. You can use substitution. The third way, in my opinion, my favorite way to do this is using elimination. Now, what is the goal of elimination? Well, the general principle of elimination is you can add or subtract two equations together, okay, if they are part of the same system, and you can do that in order to find the coordinates where they intersect. Now, why would we want to do that? Well, the reason why you would do that is so you can eliminate one of the variables. As you can see, we have two equations. Let me go ahead and number this. We have one equation here. We have a second equation here. We have two equations, and we have two variables. Now, by itself, we can't do anything with two variables. There's two unknowns, so we can't solve for any of them. But if we have two equations, then with two equations, then we can get rid of one. Now, how do we go about doing that? Well, what I like to do is this is how I teach it. I only add. I don't bother with subtraction. I want to only add the two equations together. Okay? So what does that do? Well, if you add the two equations together, if you do this correctly and set it up correctly, you're going to eliminate one of the variables. So look here. What am I looking for? Well, I'm looking for opposite coefficients. Here in the top equation, we have -4. Whoops. I hate it when my highlighter does that. We have -4, whatever. And then we have a +4 on the bottom. When we add those two together, we're going to get 0x. Let me change that to yellow just so you can get to see what's going on. We're going to have 0x, and then we're going to change this to, let's go green. Plus, we have 8x plus a -2y, that's +6y. And then -12 plus a -24, that gives us -36. Okay? So what happened here? Well, the x eliminated. It disappeared. When we added the two equations together, it went away. And that's what we want because we are left with one variable, just y. Okay? So now with just a y, we can solve for y, and we're getting somewhere with this problem. We have y equals -36 divided by 6 is -6. We are halfway done with this problem because remember, we're looking for an x and we're looking for a y. We already found our guy, Mr. Y. So now we just need to find our x. Okay, we're looking for this guy still. Now, how do you go about finding the x? Well, once you have the y, this is the part where you have to use substitution. That's why we learned substitution first, and you plug it into the y in either equation. Once you have y or x equals a number, you can plug it into either equation. So I'm going to plug it into, in this case, I'm going to plug it into the first equation, the top one, because it's just a smaller coefficient for y. Since I'm going to be multiplying, I just want a smaller coefficient. So I'm going to rewrite the first equation, okay, but this time I'm going to write -6 instead of y. -2, and I'll put parentheses. I always like putting parentheses anytime I substitute. Okay, so I substitute this value of -6 in for y. So I'm not writing y, I'm writing -6. Now, what does this do for us? Well, in this case, we eliminated a variable, and now we're just down to one variable. We have x. So we have -4x plus 12 equals -12. So we're going to subtract 12 again. Subtract 12 again. We have -24 equals -4x. We're going to divide by -4, divide by -4, and we have x equals +6. So now we're done. Why? Because we have our x coordinate and we have our y coordinate. So we can write it as an ordered pair. I'm going to do that in purple. 6, -6. What does this mean? Let's put it in the context of the problem. With these two equations, when we graph them, number 1 and number 2, if we graph those two equations, they are going to intersect at only one place, and that place is 6, -6. So that's what systems of equations by elimination is all about. Okay, let's go find a different problem. Okay, number 3 is a good one. Now, how do we go about doing number 3? Again, I like to add, so what I'm looking for is I'm looking for opposite coefficients. So if I look at x here, I have a coefficient of 1 and I have a coefficient of 2. Those are definitely not opposites, so we can't do anything there. Let's look at y now, okay? Because you don't have to eliminate the x always, you can eliminate the y. The y is technically a -1. Here we have a +1. These two guys are ready to eliminate because they're opposites. -1 is the opposite of +1. So we are going to add these two together. Let me change to green. So add them. Okay. Oops. Sorry, a little ugly here. Let me fix this. Not what I wanted. Having a little bit of technical difficulty. Then, you know what? That's good enough. Let's just go on. So now I'm just going to add. I'm going to add straight down. I'll do it in purple. So we have x plus 2x gives me 3x. We have -y plus y. That cancels. That eliminates. We don't have anything there. We could write +0y or +0, but that doesn't do us any good because it's nothing. Okay? So then we have 11 plus 19, and that's 30. So now we divide both sides by 3 to get the x alone, and we get x equals 10. Once we have x or y equals a number, we can plug it into either the top or bottom. So now we're going to plug it into, I don't know, let's see. I like to keep y positive, or, well, no, let's just go to the top because then I don't need to multiply it. But the bottom's positive y. So there's some little bit of strategy here. I'm going to go with the bottom one just because multiplying it is not going to be too difficult, and the y is already going to be positive. And the more positives you have, the better, and the less likely it is you're going to make a mistake. So equals 19. So I have 20 plus y equals 19. I subtract 20, subtract 20. I get y equals -1, and x equals 10. So what is my ordered pair? That is my solution. It is going to be, what color did I use last time? Purple. So I'll use purple again. So my solution is going to be 10, comma, -1. Final answer. Okay, let's find an example where we have to do some changes. Okay, number 6. Check this out. 8 and -3 are not opposites. Y is +1 coefficient, +1 coefficient in the bottom. So those aren't opposites. So what do we do? Do we give up? What do we do? What I like to do is I like to change it so that they become opposites. Well, how do you change an equation? Here's 1, here's 2. Well, you can change either one of these. In this case, I want to change the top one. Okay, so I'm going to change the top one. And what do I want this coefficient of y to be? We're always going to choose the one that's the easiest process and the one that we only have to change one of the equations if possible. In this case, we do. It's easy to change this to be the opposite. We want it to be -y. So what do we have to do from y to get to -y? Well, that is multiply by a -1. But if you multiply by -1 to the middle term, we have to multiply by 1 to all the terms. So what we're going to do here is we're going to multiply this whole equation by -1, and we're going to multiply each one of these terms so we can get our -y. Now what happens? We're going to get -8x minus y equals +16. Okay, I'm going to rewrite equation 2 right underneath it. I have -3x plus y, I don't want to change this guy, equals -5. Now, let's see where we stand. Well, here we have a -1y and a +1y. Those are opposites, so guess what? We are ready to proceed. We can go ahead and add these two equations because they're going to eliminate. Remember, only opposites can eliminate once you add them. So we're going to add -8x and -3x. That gives us a -11x. These canceled, okay? 0. Then we have 16 plus -5, that's 11. So we divide by -11 to both sides to solve for x. We get x equals -1, okay? Once we get x or y equals a number, in this case we got x equals -1, we can plug it into either equation. And we can even use one of the equations that we modified. We can use this green equation, we can use this pink equation, we can use this equation over here, we can use this one. It doesn't matter which one we use. We just have to plug it in to x somewhere. So I'm actually going to use equation 2 because it has the smallest multiplier of x and y is already positive. Makes it a little bit easier. So you have -3. I'm going to put parentheses here. Oops, that's not a parenthesis. Parenthesis, plus y equals -5. So I'm plugging -1 here. We get +3 plus y equals -5. Subtract 3. I get y equals -8. So now I have my x, I have my y. I can write it as an ordered pair. And that is the location in which these two intersect. Okay, now let's talk about, I wonder if there's a special case here where they both eliminate. I don't see any off the get-go, but there is a couple circumstance I want to talk about, and that's if the equations don't have an opposite and we have to multiply by something more than -1. Okay, so let's take this one, number 11. Okay, so number 11, the x's are not opposites, the y's aren't opposites, so we got some serious issues going on here. What do? Well, I'm going to try to make it the easiest possible. If I tried to get the y's to be opposites, what would I have to do? Well, I would need to multiply the top by something and the bottom by something in order to get them to be opposites. I could multiply the top by -5 and the top by 7, and that would make them opposites. What would happen there? We'd get positive 15x, because I distribute this to all three terms, minus 35y equals, what's 16 times 5? 16 times 5, 6 times 5. Sorry, I'm going to just go ahead and do this. Easier than using a calculator. 380. Okay, so then it equals positive 80. And then in the bottom, we would get negative 63x, because I multiply it by 7, positive 7 to all three. Negative 63x plus 35y equals 80. Okay, so I would get opposites this way, but there's an easier way to do it. Always try to take the path of least resistance when trying to do elimination, okay? That's far too complicated. So you can do that, and in some cases you will need to, but there's an easier way in this case, okay? The easier way here is to get the x's to match up. So let me go over to the x's here, okay? If you notice here, it'd be easier to get the x's to match up because this is a factor of this one. So 3 is a factor of 9, so we only need to multiply the top equation by -3. So I'm going to go ahead and multiply the top equation by -3, and this will be much easier. So I get 9x minus 21y equals, was that positive 48? Yeah. I'm going to rewrite our second equation. Okay, this was 1, this is 2. So I'm going to rewrite our second equation, negative 9x plus 5y equals 16. So you see this is a much easier problem because we only had to multiply one of them to get the coefficients to match up for one of our variables. Now we see that the coefficient of x are opposites, and we're ready to proceed. We're going to add these two together, add, and it eliminates the x's. Okay, and we add the y's, and we get negative 16y equals, what is that, 64? So we are going to divide by negative 16 to both sides, and we are going to get y equals -4. So we're halfway there. Now we need to substitute this into either equation. I'm going to substitute in equation 2 just because it's smaller coefficient. I have negative 9x plus 5 times, that's where I'm going to insert my value, equals 16. -4, because that's what y equals. So I have negative 9x minus 20 equals 16. I'm going to add 20 to both sides, add 20 to both sides. I get negative 9x equals 4. Did I do something wrong here? Or is that just how it goes? Let's see. 4, 9x, plugged it in for y. Minus 20. Oh, I'm sorry. That's not 4. That's 34, isn't it? That's 36. Still going to something wrong. All right, negative 9 divided by negative 9. I get x equals, what is that, -4? Yeah, it is. So our final answer is going to be -4 for x, -4 for y, and there we go. Okay, some words of caution. Okay, some of them you're going to have to multiply both equations like I kind of demonstrated the first time. And maybe I'll make a part 2 of this. For now, I'm going to leave it at this. I probably will make a part 2 just because I think it's a little necessary. Yeah, I'll make a part 2, so stay tuned for infinite solutions and no solutions type of problems. And we're also going to do when you have to multiply both equations. So stay tuned.